Welcome everyone to the 10th episode of the Science and Healthcare Sustainability Podcast. It is a milestone and we're absolutely delighted to have Noah from Polycarbin with us today from the US. So we're going to get a great perspective on sustainability and recycling over in what is probably the largest research market in the world. So yeah, welcome Noah, great to have you.
Thank you so much. I appreciate being here.
No problem at all. First question. It'll come as no surprise to anybody that's listened to this podcast before. What is sustainability to you?
It's a good question. For me, I guess it's a kind of aspirational standard for design and engineering, which is like, don't just design something to complete a task, but engineer it to the point that you are maximizing the efficiency of resource utilization and minimizing output and waste. And so I think a lot of times we kind of view things as a means to an end. We kind of think about it, is it good enough? And instead it's the continued pursuit of making sure that it not only does its job, but does so with minimal impact on the environment, producing as little waste as possible.
Great answer.
Yeah, absolutely good answer. And from your perspective or the work you've done in your domestic market, what is the scale of the problem in laboratories in the US in particular?
I have been for 4 years quoting the same statistics that everyone quotes, which is that 5.5 million metric tons globally for rigid plastics every single year. And it's funny because that is like a non-rigorous estimation from a 2015 Exeter University study that all of us kind of use to frame the scale of the problem. But honestly, it's the scary part about the scale of the problem is that we have no idea. We actually don't know how bad it is. And we know that the market grew by 5% year over year for the past decade and is projected to grow by nearly 9% year over year for the next 10 years. And so there's a good chance we're massively underestimating the scale of the problem, especially in the United States, especially after COVID, and that it could be even greater than that statistic we quote all the time. So we know it's at least 12 billion pounds as of 10 years ago, but it could be greater.
Yeah, it's scary.
Yeah. So tell us a little bit about Polycarbin. What is it that you do and where you do it?
So we're a circular economy platform for laboratory consumables, scientific consumables. We fundamentally work with scientists in the laboratory to help them recycle single-use consumables. We provide a data platform where we monitor the amount of material that we're diverting from landfill. We track and audit our processes, so we provide data on CO2 emissions, freshwater conservation, fossil fuel displacement for those customers. And then most importantly, we bring that resource back into production in our circular supply chain to turn into new products, new laboratory products like pipette tip boxes, 50 mil conicals, 15 mil conicals, ultimately creating a circular economy. Our goal as a company is to recapture as much plastic as possible and then reuse it as much as possible in the exact same ecosystem filled with climate conscious scientists that are going to help us maximize the use cycles of every pound of plastic we produce.
Amazing. Yeah. Just picking up on something you said then about environment conscious scientists. Is that commonplace in the US? Is there a driving force behind what you're doing coming from the labs? Is this what people want?
Absolutely. We have been quoting this ever since we did the study. It's probably due for an overhaul, but in our mind, there's 3 categories of people in the laboratory. There's 8 out of 10 people that care about sustainability and are willing to act on it. There's 1 person who's a zealot about it that's willing to go above and beyond their daily work to do something about it. And then there's always 1 person who says, I don't care. But with that ratio in the consumer base, it's very easy to build a company. It services that demand and kind of scratches that itch.
Yeah, brilliant. And I imagine there's not many people doing it as well. So there's a big demand and also there's very few companies like yourselves fulfilling it.
It's wild. We've been in this business now for 5 years and we've seen we're really hitting an inflection point. Yeah, there was no recourse for recycling in laboratories basically when we got started. And now we're seeing incumbent brands, take this a lot more seriously and realize that you can continue to try and differentiate on spec for the next 10 years, or you can differentiate based on EPR or sustainability or sustainable content in your products. And that's the new winning strategy. And a lot of brands are really resonating with that. a lot of the ones that are working with us really recognize that the way to the future is to recognize that scientists are humans that care about more than just the efficiency of their assay. They also care about the impact of their work. We know that science is 95% failure. We want to make sure that 95% of the time it doesn't work, or that it is a, iterative step in a direction of success. We want to make sure that it doesn't create unnecessary gratuitous waste.
Yeah, good point. And when did you start the company? Did you say it was 5 years ago, or was it beyond that?
We incorporated in 2020, early 2020, but there were kind of early thoughts on the company in 2019 with me and my co-founder, James O'Brien. We were at the University of Pittsburgh School of Medicine. We were training to be physicians. We were in a 5-year program where we do a research year in the middle after our boards. And it was in that research year that he and I kind of realized that we were just told this stuff wasn't recyclable, but there was no reason for us to believe that. And when we asked people, they would always tell us like, oh, it's not technically possible, or that like customers don't want to recycle, or that, if you did recycle it, customers don't want to buy the plastic on the back end, and absolutely will never buy a product made with recycled content. And so we decided, let's kind of like take it back to first principles and test those assumptions. And then we kind of didn't look back because we saw an enormous amount of success.
Brilliant.
So was that a bit of a light bulb moment for you as a kind of, trainee physician, you say? Was that the light bulb moment where you thought, I can knock this on the head, I've got a good idea?
Honestly, it didn't even feel like a good idea. Plastics isn't like I'm, generating a new like large language model, It's not cold fusion. It's just an antiquated technology that hasn't been applied to our industry because of, lack of follow through and a disconnect ultimately in incentives. And so what we realized is that if you could own end to end the entire process and you could deliver for scientists the data and the material to prove that the recycling is real, all of a sudden that was the key, that was what was missing. And so shunting this material into an industrial industry, or one where you don't know if it'll ever be recycled again and no one's counting the data, no one's telling anyone whether or not it's really sustainable, that lack of transparency was kind of the problem. And so I'm not going to sit here and pretend like we, invented something technologically superior to what existed in the past. And instead, it was kind of just recruiting a bunch of existing technologies and applying them holistically into our circular economy platform, and then ultimately delivering for the customer what they expect, what they want out of recycling. And that's transparency and data.
Brilliant.
Can you give us an idea of kind of the size and scale of your operation in the US in terms of, how many customers have you got? How's it taken off for you?
I actually have no idea how many customers we have now. We are in thousands of labs. We're doing
That's good.
millions of pounds of plastic. We have operations in Northern California, Southern California, New England. We're opening up operations in the Mid-Atlantic region to service more customers down there. We're servicing customers in Canada, and as we talked about a little bit before, we're looking into expanding into the UK as well. What we have found is just a completely unmet demand for recycling and for sustainable products that are powered by, again, data. And so we've been really fortunate that the bet that we made early on was that, I'm a scientist. I create a bunch of plastic waste. I would care a lot if I had an opportunity to recycle it. That was actually a generalizable assumption in our industry. So, we've been very lucky to scale pretty quickly.
That's brilliant. We work with Recycle Lab in the UK, and we're putting a lot of time and effort into educating scientists and talking to scientists about what's possible with that service. And it's great, really reassuring for us to see that actually the model does work and it can be scaled. Recycle Labs, I'm sure they won't mind me saying, are still relatively small with a small number of customers. As I said, knowing that it's been done in the US, it has to transpire globally, doesn't it? It has to work everywhere. The model has been a success for you, and it must be a success everywhere else. Can you talk to us specifically about the service? It's a box service, and then the customers can buy back the plastics. And what specific plastics do you sell?
Yeah, so we started out as primarily a local service where we had a truck and we were picking up, anywhere between 500 pounds to 2,000 pounds of material from some larger customers in the Bay Area and Southern California. That's how we got our start. And then we launched a service where we could essentially have people mail back their plastic, any brand agnostic, and we'd be able to recycle it. And one of the things we learned was that in order to be successful in this space, you had to reach platform scale. Otherwise, 2,000 pounds of plastic in a warehouse isn't really relevant to anyone. But if you're moving 50,000 pounds a month, all of a sudden the access you have to equipment, to partners, to network, to R&D, that expands. And so that was a major reason we were able to kind of grow this into a more sophisticated platform that then picked up new streams of material. And so to circle back to your question, we went from focusing solely on rigid plastics to now expanding to nitrile gloves, non-woven polypropylenes, polyethylene, flexible packaging. We do selective glass, Pyrex, borosilicate glass recycling in parts of the United States, EPS if it's local, because again, we do everything by the data and it's not actually carbon efficient to transport EPS long distances. And then am I leaving anything else out? No, I think those are the big ones for now.
Brilliant. And how do you deal with the hazardous question? A lot of these products have been used in science that is potentially contaminated, or there's products that you wouldn't want to get into the waste stream. How do you deal with that?
Yeah, so fortunately, laboratory environments are highly regulated, tightly controlled, and often modularized work environments, which means that the places where you want to keep the virus and keep it away from the rest of the people are usually siloed to a special part of the laboratory with air control, and you don't have to have significant concerns as long as you don't put a box in there that some AAV covered tissue culture flask is going to end up in your bin. Now that said, there are errors that can happen. There's still hazardous reagents and solvents that can end up on plastics, and so part of the onus is on Polycarbin to create an educational platform that works with on-site EH&S. That's what we call in the United States. It might be called something different in the UK, but environmental health and safety workers at different facilities to make sure that we are compliant with their institutional standards, the local standards, and the national standards for safety. We take that really serious. We do compliance testing with all of our customers, and so we track everything that comes in. It gets a picture taken of it as it's being scanned in. Anything that is flagged as containing infectious material or a potential P-list chemical or anything with a GHS pictogram of a skull and crossbones or like the exploding chest, we're going to flag that. We're going to create a report, do a root cause analysis, find out what happened, and then ultimately either re-educate the customer on kind of what the standards are, figure out if there's a misunderstanding, and in cases where we have repeated infractions, we're ultimately just going to terminate the service. We like to say that, you can't be sustainable unless you're doing it safely. And so we take this part really seriously. And to answer your question in a simpler way, it just comes down to like the fortification of education they already have.
Yeah, good point.
So what would you say was the most wasteful part of what you do? And how do you mitigate that? What are the most impactful changes that you've made to the way you work based on experiences?
We quickly found out that there was a near infinite demand for recycling services, and we could not produce enough products fast enough to put all of the material that we were recycling into production of our own products. And so the most wasteful thing was that at the end of 2024, only 48% of the plastic that we were taking in was going into laboratory product manufacturing. The rest of it was going into consumer good manufacturing like non-food packaging, paint buckets, bales, automotive industry. And so we built this company because we want to have closer to that 100% circularization rate. We want really high recovery rates. And so the innovation we made was basically saying, we're not Eppendorf. We're not Mettler Toledo. They have hundreds of molds with like infinite capacity to produce almost anything a scientist could need. And we're not going to rebuild that business. Instead, we want to work with those types of businesses to supply them this resin that comes with ISO compliant data so they can deliver the narrative and story that we're ultimately telling, but it can come in the form of already spec'd in products. Like if you're in Eppendorf, you spend a year winning a contract with an operation like LabCorp or something like that, some CRO that is really, persnickety or very careful about changing products. If one of those brands is going to be using a specific product from a large incumbent brand, they're not going to change unless you do a ton of testing, a ton of new spec. And so it's easier for us to basically bring our resin to a company that's already an established brand working with those groups than it is for us to try to remake a product that competes with that. And so instead of chasing our tail, we're just partnering with brands like Novus Bio, LabCon, Beckman Coulter to deliver for scientists products they trust with resin that helps them hit their sustainability goals.
Yeah, that's brilliant. Great idea. And it's interesting that your biggest challenge, it sounded like, was you were a victim of your own success in terms of buying into the recycling. You ended up with too much material I don't think you should kind of sniff at the fact that you actually did recycle that 60% as well. Although it didn't end up in lab plastics, it was still going back into a plastic product. So it's still a win, I would say, for the environment, but it's not quite the gold star that you wanted when you first set out. But are you at 100% now? Is that where you are?
We're not at 100% yet, but we're growing quickly based on the brand partnerships I mentioned. Novus Bio in California is one I want to shout out. They're going to be launching an entire product line of universal fit filtered pipette tips made with our resin. They're going to be a great partner for ensuring more and more of this material is ultimately going into circular economy endpoints. But I do want to emphasize that, part of our brand is supply chain transparency. And so within our LCA, we did both a cradle to cradle and cradle to gate analysis so that we could essentially measure the impact of producing a pellet that is then can be universally input into any injection mold. And we measure the sustainability of that. And then we measure all the way to the point of producing products. These are measured separately. So all the plastic that goes through manufacturing is separately measured and taken into account in terms of the specific carbon footprint of product manufacturing for polycarbon. And then there's a separate analysis that is in the carbon counter that goes into plastic that ultimately goes into the form of a pellet that goes into a separate industry.
Brilliant. So knowing what you know now, what would you tell yourself sort of 5 years ago when you were setting up? Was that the golden sort of egg partnering with these manufacturers, or is there something else you've learned that actually you could have done better from the start?
Probably the most important advice that I would give myself and any entrepreneur is that early on, write down what your metrics are for knowing whether or not you're being successful. It's not about just raising money, or it's not about just generating revenue. Your North Star needs to be specific to who you are and what you're trying to accomplish. For James and I, we want to be able to leave this company knowing that we produced a megaton CO2 emission reduction. That's what we want the legacy of the company to be. And so that continues to be our North Star. In addition to that, I do a lot of talks where I actually talk to young entrepreneurs. And so forgive me, this is probably going to be a pretty long answer. But another one is basically the importance of SOPs, workflows, and data management early on, because when you start a company, you don't have data. You're just operating on hunch. You're this is what I think I know about the customer. This is what I think a good value proposition would be for that customer. This is a good commercialization strategy. This is a good go-to-market strategy. And you repeat these over and over and over again to yourself. And then you stop testing them and you stop questioning them. And what you find is that all of a sudden, 3 years later, you have a ton of data, but you're not using that data to challenge those kind of first principle, kind of foundational assumptions you made about your business. And so one of the most important things I've learned in the past 2 years is once you have scale and you have data, go back, revisit those kind of foundational assumptions and test them with the data and see if it bears out. It is shocking how many times something you think is fundamental to your business doesn't bear out in the data, or it's superfluous, or sometimes non-value accretive or wasteful. And so it's really important to kind of look back to the time where you didn't have data and you made assumptions and test those.
Yeah, great advice.
Do you think that labs can ever become carbon neutral? Or is some waste going to landfill always going to be inevitable?
There's 2 ways to answer this. I think there's one where you're saying, can they be zero waste, and then can they be zero emissions? It depends on the definition we're looking for here, but I mean, if you put a big gigawatt windmill at your facility, you can be pumping energy back into the grid, and you can be carbon negative if you want. But specifically answering the question in terms of zero waste with the plastic industry or true 100% circularity, no, we can never do that for some of the reasons you guys brought up already, which is that fundamentally we as scientists have to work with particularly hazardous chemicals. And there's really nothing that I can do to build out a technological solution for recycling high concentrations of sodium azide or, radioactive material. It is probably technically possible to recycle that, but it's not worth it because it's a small fraction of the waste stream. It would be unsafe and the risk would be too high and the cost would be too great ultimately. And so some of this plastic is headed for incineration or landfill, depending on what the most sustainable solution is based on geography, based on state regulation. But we are so far from better that it's kind of a question that should not discourage anyone, right? Almost by the actual percentages, almost none of this material is recycled right now. And so we have a long way to go. before that question actually should start to enter our mind and inhibit where we think we're going. And two examples I use when I think about this is the automotive industry in the United States alone recycles 95%, over 95% of automotive steel. It's like the United States recycles 95% of all automotive steel. Nobody knows that. And nobody knows that like over 60% of it goes back into more automotive steel. It's like a true, efficient, beautiful circular economy that's been in existence for like 50 years. And we don't just do it because it's like more cheap than sourcing virgin steel. It's just because it's largely because of World War II and we built out the infrastructure for it, but it was prioritized by manufacturers and consumers as well. And so we can do the same thing and we can achieve similar results. We could even end up like copper, where I think 30% is circularized material in the United States. Like if we were as good as copper, our industry would be crushing it in terms of reducing its carbon impact. So we are so far from even better that we shouldn't even be looking at what perfection is and whether or not it's achievable.
Yeah, I think that's a great answer. We often talk to labs in the UK about just making some marginal gains and it will make a big impact. Just the simple things that people like my green lab advocate for, turning off lights and those kind of things. Get those basics in first and then look at the grander ideas. I take your point.
We're honestly fortunate as an industry because our biggest source of emissions is coming from single-use consumables. We don't have the same problem as like the automotive industry or energy grids that like genuinely require new national infrastructure to provide liquid natural gas or renewable energy to power it. Instead, we literally just have to be more responsible stewards of plastic and we can make a huge difference. Like we're in a good position in terms of how we can meaningfully, measurably go after our largest carbon footprint.
Yeah, you're right. There's a big target, isn't there? And the means to attack it as well, which is great. If you were President Trump and you could sign an executive order to change 3 things in labs overnight, what would those 3 things be? Would it be recycling and implementing your plastics, or is there other things that you've come across that you think that's a great idea?
I'm going to answer this in the terms of practical solutions that if I could change them today, they would sustain and not be costly and not be ineffectual in 10 years. So number one, we now know we can produce pipette tip boxes out of circular economy resin. The notion that there are any more boxes being made out of virgin material today is so wasteful and frustrating. It's like hard to stomach. And so number one, I would just swap out the manufacturing of all pipette tip boxes with circular economy resin. That's the biggest one. Number two, I would create a mandate where all brands have to provide customers the option for a take back program. It just has to be an option. We can't just continue to rely on the individualization of responsibility where we produce products that we allege are compostable, biodegradable, recyclable, and then just let the customer go figure it out. It is the responsibility of the manufacturer to provide the actual option for recycling or composting or biodegradability if there is such a thing. You need to be able to provide that service, otherwise you shouldn't be able to make the claim that it is recyclable or compostable. And then the last one would be, because I'm in operations, I think of everything in terms of equipment. So if I could just give every laboratory a small baler and a small shredder so they could on-site densify this material so it doesn't have to be transported as 90% air volume, then we would have the most efficient system for dealing with this resource. And
what we did.
Yeah, exactly.
Yeah, so, that's a great answer.
Those are my 3.
Okay. And is sustainability worth paying for, or should it be cost neutral in order for people to start jumping across?
I think baked into this question is the premise that sustainability and to be sustainable is always more expensive. And I think you can kind of...
It's not the case as much as it used to be.
No. And it's like the examples I would use is like it was cheaper to pour used motor oil into sewers in the United States for a long time. And then we made it illegal, It was cheaper to pour organophosphates all over crops. And then we made it illegal to do that, And so the non-sustainable option is always cheaper until you can't do it anymore. And I can use California as an example. There was a bill that came out back in 2022. I think it's AB 1875 or something like that, where they basically reclassified waste to energy as just another form of disposal. It doesn't count as recycling anymore. And so immediately, all the waste to energy in California started shutting down. So now people have to send their waste to energy out to other states, sending it 1,000 miles away. all of a sudden recycling this material is the most cost-effective alternative to landfill. And so sustainability in the state of California, especially in Southern California, is the most sustainable option. And so, not really answering your question, but I guess I'll say that when you take into account externalities, the cost of pollution, the cost of, having 500 parts per million CO2 in our atmosphere, when you take into consideration the ramifications of climate change, I don't know if it is necessarily more expensive.
So we touched on this earlier at the beginning, but what plans do you have immediately for the business? Is there anything that we can look forward to and keep an eye out for?
Yeah, we're expanding in Canada, announcing a couple new brand partnerships for putting closed resin into manufacturing. And then the UK expansion, which we're hoping is happening this summer, maybe into early fall.
Brilliant. Yeah, the UK is so receptive for this kind of thing, and often there's a compromise that has to be made in laboratories at the moment between boxes that can accept gloves, boxes that can accept hazardous material or not hazardous material. And I think you coming to the market is going to be a really positive change.
Yeah, absolutely. What other products and services from other suppliers would you recommend scientists use that you see having an impact that you come across on a kind of day-to-day basis?
I mean, right off the bat, Novus Bio in California, they really leaned into this circular economy resin. Highly recommend looking into them. LabCon, Beckman Coulter are moving in the exact same direction. We have exciting partnerships with them. But in general, I would just prioritize brands that treat sustainability like a science, demonstrating a quantitative commitment, not a qualitative commitment. And then especially brands that engage in extended producer responsibility. Someone who gives you an option to be more sustainable is somebody more committed to the cause and more reliable as a partner than someone who's selling you a product that alleges to be sustainable, and it's up to you to figure it out.
Yeah, brilliant. Now, any plans to come to the UK in person?
Maybe in late June. That would be either just James, my business partner, is going to be there, or maybe both of us. Not sure yet.
Brilliant. Well, we'd love to meet you in person if you're in our neck of the woods. Before you go, is there anyone else you'd recommend that we have on the podcast? Anyone from the companies you mentioned or wider afield that you think would be great to have on?
I got to be careful with NDAs here. I can provide some offline that I think would be really good, especially the scale they operate and the types of projects they're working on. But one that I know that I can share on the podcast is Ed Krazunas. He's based out of Connecticut. He's a brilliant guy. He's a great storyteller. He's been working in the regulated medical waste space for like 40 years or something like that. He has seen this industry change, and it's really inspiring hearing him talk about it, because you actually see, like, we all are dejected by the current state of how things are handled in the United States, and yet it has made just absolute quantum improvements, and we're continuing to see that happen faster and faster. And so I think he could serve as a great resource for kind of an optimistic perspective on how this industry has changed and where he thinks it's going.
Brilliant.
Yeah, we'll be sure to look him up. Well,
I can introduce you guys.
Yeah, perfect.
Fantastic.
Perfect.
Thank you.
Well, Noah, thank you very much for your time. Anybody watching, hit like, subscribe, and don't miss the next one.
Yeah, thanks, Noah. Absolute pleasure to have you on.
Been great.
Thank you both. I really appreciate the time. This was great.
Science and healthcare.